I love being a software engineer because of how easy it is to build side projects. And I've built countless side projects. I've built a social gambling application, a dating website backend that had 0 users, a stock trading music rhythm application for Android. And I think every developer should have side projects. So when I have a web app that I want to deploy and share, I want to show my friends my most recent project that nobody will care about, I use DigitalOcean to quickly spin up a server and host my projects. And who knows, if one day one of my apps takes off and goes viral and people actually do care, I can easily scale using DigitalOcean's flexible pricing plan. Companies like TaskRabbit that have grown rapidly have used DigitalOcean for this very reason. But until this happens, I will happily stick with the $5 a month plan. Sign up with promo code SEDaily to get a free $10 credit as a listener of our show and start building your apps. We would love to see what listeners build, so send us an email showing us your project. I've also interviewed Moise Uretsky, who is the co-founder of DigitalOcean, and he mentioned that the ease of use and the flexibility is why they built the service in the first place. That DigitalOcean interview is one of my favorite episodes. Moise talks about bleeding in a data center. He says, you don't know how hard it is to do a cloud hosting service until you've bled in a data center. It's really interesting. So speaking of which, let's get on with this episode of Software Engineering Daily. Apache Drill is a schema-free SQL query engine for Hadoop, NoSQL, and cloud storage. Tomer Shiran is the founder of the Apache Drill project and the CEO of Dremio. Tomer, welcome to Software Engineering Daily.
Thanks for having me.
I'd like to start off by talking about SQL. Over the past decade or so, we have gone from the exciting introduction of NoSQL databases to the realization that we still need SQL. Can you describe this evolution?
Sure. I think I think what really happened here is that NoSQL databases came along and basically solved some serious problems that people were having with relational databases. So, for example, they solved the scalability problem. They made it easier for developers with very kind of clean and developer-friendly APIs. But I think at the same time, what they didn't do is provide kind of a good way for people to analyze that data, right? And SQL kind of remained that language, which even if a developer doesn't need that for building their web application, you have millions of analysts and other business users that know SQL and tools that know SQL and speak SQL. And so now we're getting to that point where people have realized that, okay, they still need that query capability in order to analyze all the data that's going into these systems.
Can you describe in more detail how NoSQL solved the scalability problem that you referred to, and what other problems did NoSQL solve?
Sure. NoSQL databases, and I really hate the term NoSQL. It's because, like you said, now people are bringing SQL to NoSQL because they realize it's important. But, nevertheless, this collection of databases, things like MongoDB and HBase and Cassandra, and even technologies like Solr and Elasticsearch are serving a very, very important purpose. And so the first problem that they solved is basically the scalability problem. So traditionally, if you wanted to store a lot of data in a database, you'd have to buy a very, very big machine with a lot of memory and a lot of very high-end storage. Well, something like an Oracle database. And that was very expensive to scale up, both on the hardware and on the software side. And then it also hit the limit. At some point, there's just no machine that you can buy that's big enough to do what people are trying to do today with all the new kind of data that they're using. And so that was kind of the first problem. The solution to that was really these kind of scale out architectures. So kind of first pioneered by companies like Google, where it was all about taking more commodity servers, standard kind of off the shelf servers, rack mounted servers, and basically pulling together a group of those servers so that you have effectively what's one database, but actually physically is running across many of these servers. And some of these systems could scale to thousands of these servers.
In the current state of affairs, NoSQL often means not only SQL, and you've referred to this in some talks that you've given, I've seen. We have polyglot persistence these days, or at least we have polyglot data access. So fundamentally, is there a reason for this polyglotness, or is this variety of data formats, is this kind of a case of technical debt across the industry? Like if we could magically give a facelift to the entire industry and standardize the data format, would we actually want to do that?
I think what we're seeing is we are seeing some standardization in kind of the data model. So traditionally, the traditional data model was the relational data model. So you had kind of a fixed set of columns, and then you'd have many, many rows in a table, and those columns very rarely change. So it's kind of a rigid schema. What you're seeing now, and especially with JSON, is that has kind of emerged as a standard way in which applications can save data, persist data, whether that's storing JSON documents in a database, things like MongoDB, or it's APIs, online APIs, right? So virtually every API these days for every SaaS application is based on JSON. So that's kind of emerged as the standard way to represent data.
Okay, so we have this kind of strange scenario where JSON has been standardized on the format that we're storing data, but we still want to access it in the format of SQL. So at this point, I understand the situation. I know what SQL is, and I know that my things are being stored in JSON. So SQL is the structured query language that I often use to access a database. And eventually we're going to get into Drill. But before we get into Apache Drill is a SQL query engine. Can you define more broadly what is a SQL query engine?
Sure. A SQL query engine, at the end of the day, it starts with the SQL language, right? So SQL is a declarative language that people can use and tools use to describe how to retrieve data, right? So given one or more tables of data, I can write a SQL statement that basically says what data I want to retrieve and what kind of transformations I want to do on that data. So an example would be I only want to select some of the columns in those tables, or I want to join two tables on a specific key, or I want to aggregate data by a specific column. So maybe I want to aggregate the salaries of employees by state in which they're employed. So that would be an example. So SQL is a language that basically lets you do that in a very simple way. Typically, a paragraph would be the size of a SQL statement in many cases, versus having to write a lot of custom code in a language like Java or Python. So that's kind of what SQL is. Now, a SQL execution engine or a SQL query engine is basically a software technology that takes a SQL statement, something that's written in that language, and then compiles that and runs that on the data, right? So it takes the language and basically runs whatever is specified in that statement and returns the results to the user.
Let's motivate the discussion of SQL query engines a bit more with a use case. So let's say I'm a business analyst and I'm working at some company like a giant pharmaceutical company. It's a decade old. There's a huge amount of data in all kinds of different formats scattered across different servers. And I'm a business analyst, so I don't know much about programming. I don't know about Hadoop. Maybe I just know a little bit of SQL. Does a query engine like Apache Drill fit my use case?
Yeah, that's exactly what Drill is designed for. So for some background on Drill, one of the unique things about Apache Drill is that it allows you to run SQL queries on one or more disparate data sources. So if you're an analyst sitting there and you have data in different locations and you want to join that data or gain insights from bringing together multiple data sets from different places, you can use Drill to run that query. And then, depending on how technical the analyst is, they could either use Drill directly and write their own SQL statements. And so there are millions of people that know how to write SQL. And then some users don't know how to write SQL or prefer to use a BI tool like Tableau or Click or Power BI or even Excel. And those tools can speak to Apache Drill using the SQL language and provide a much more visual experience for doing such data analysis.
So we have this prototypical use case of the business analyst operating a laptop that is pointed at somewhere with heterogeneous data. Are there any other prototypical end users that we can use as an example to think about the uses of Apache Drill?
Sure. I think when you look at Apache Drill, there are a number of different personas that find the technology very interesting and useful. So the kind of end user in many cases is that business analyst, the Tableau user, for example. But in many cases, we also see the developers or data engineers using the technology as well. And what they're finding is that it's useful for them in one of two ways. So the first way is, in many companies, the users that want to that need kind of to explore data or to analyze data, they will actually go to a developer and say, "Hey, can you tell me what the top 10 restaurants are in this region based on the data that we have?" Right? And then the developer goes and does a bunch of custom work and gives them the result. So for those developers or data engineers, being able to provide a self-service solution for the business analyst is a very valuable thing, so that they don't constantly need to kind of provide the answers, right? It's more about teaching them to fish as opposed to giving them the fish. The other important kind of use case here for a data engineer or a developer is, at the end of the day, writing a SQL query is going to be a lot easier and far less code and less work than having to write custom code in order to bring data together from multiple data sources and make sure that data pipeline is always up and running and do all that data munging, if that's something you can just represent in a single SQL statement. So for a developer or a data engineer, it just saves them a lot of work, and it's very easy to get started.
We'll get to the direct discussion of Drill, but Apache Drill is based on Google's Dremel system, much like Hadoop was based on the MapReduce paper, and other open source technologies have been based on these various Google papers. So what is Dremel? What was Google trying to solve with the Dremel paper?
Yeah, so Google. So first of all, I would say Apache Drill is inspired by Dremel, not based on Dremel. Dremel is an internal system at
sure.
Dremel's an internal system at Google. So Google built Dremel as a system that enables interactive kind of ad hoc SQL queries on large clusters of commodity hardware. So Google already had a MapReduce system when they developed Dremel. MapReduce was really designed for batch processing, and so something you would run a job every night, that kind of work, or every hour to process a large amount of data. Not a very good fit for, say, an analyst or a product manager or somebody who needs an answer right now and they're sitting and waiting for the answer, right? So for that, you really need to optimize for kind of low latency as opposed to being able to run a 3-hour job. And so Google built Dremel as an internal SQL solution that runs on a large cluster of servers, can analyze data very fast. It combined kind of a SQL execution engine with a special, what's called a columnar format that Google had developed internally, called column IO, that allowed those queries to run really fast.
Okay. And so this was around 2010, I think, that Google published the Dremel paper. And around that time, the Hadoop querying systems were Pig and Hive. What are Pig and Hive, and how did the Dremel strategy compare to Pig and Hive?
Yeah, so in the Hadoop, one of the great things about Hadoop and the open source community in general is that you get a ton of innovation from different companies, right? And so you get different projects and taking different approaches and a much broader ecosystem than you would get if you were just kind of one company building a proprietary technology. And so what happened in the Hadoop ecosystem is we had a single execution engine called MapReduce at the time. And what people realized was that, beyond just the challenges of how kind of the execution, the time it takes to run a job, there were other challenges with MapReduce, which is that you really had to have a strong Java development background in order to write one of those MapReduce jobs. So it wasn't something that you could take an analyst and have them write MapReduce jobs. And so 2 layers were basically developed on top of MapReduce. So Facebook built this system called Hive, which basically took SQL queries and compiled them into MapReduce jobs. So it was still, at the end of the day, MapReduce jobs that were running, but the user was basically submitting a SQL query. Pig was another approach to do something similar. It was kind of more of a new scripting language that was built on top of MapReduce, a little bit more procedural. so you could do slightly more complicated things. It was great for kind of ETL type workloads, data transformations. But again, you didn't have to write Java code in order to actually write one of those.
Okay, so now you've given us a picture of what the Hadoop query language landscape looks like. And then Google publishes this Dremel paper, and Dremel was eventually, like you said, the inspiration for Apache Drill. So to put a finer point on the important aspects of Dremel that were inspiring, what was the initial spec for Drill? Like, what were the initial goals of the Drill project that were taken away from Dremel or inspired by Dremel?
Mm-hmm. So Dremel did a few things that were very interesting and very valuable. It introduced kind of an architecture for running very large SQL queries on, when I say large queries, I mean large amounts of data. So being able to run on a large cluster of commodity servers and return fast results. So that was kind of the biggest innovation that Dremel provided, as well as their kind of columnar format that was suitable for complex data as well. And so those were kind of the things that we looked at Dremel, and we said, well, we need to bring this to the open source community, to the broader industry as well, so that other companies and organizations ranging from small tech startups to the largest enterprises would be able to have the same benefits that Google has internally with this system. Now that also meant kind of understanding that Google had internally they could take some kind of relaxing assumptions, right? It was very different from an enterprise that had all sorts of legacy systems and was bringing data from many different kind of heterogeneous sources, whereas within Google, all data was basically being generated by their own internal system. It was very kind of homogeneous in nature. It was all in a specific format called protocol buffers, whereas other companies, the data was in all sorts of formats and all sorts of systems. And so it required a lot more flexibility, right? And so we embarked on kind of a journey to build a system that would take the best of Dremel, but also provide a much greater level of flexibility. And we spent about 3 years building that until in the middle of 2015, we finally had a release that people could start using.
Can you talk more about the historical context, the anecdotal context of how the ideas from Dremel started to percolate into a project that would become Drill? Like, what is the story? Who were the individuals and companies that were involved?
Sure. So at the time, I was VP of product at MapR, which is one of the large Hadoop vendors. And we were thinking about, okay, how do we make Hadoop more broadly applicable to a larger audience? Because at the end of the day, when you were going to companies that didn't have large engineering teams, think about kind of regional banks and those types of kind of mid-market companies, they really struggled, right? You had this massive massively parallel, very scalable platform, very powerful platform. But at the end of the day, you need users that are and companies that don't have a ton of resources to be able to take advantage of that and to be able to analyze data. And so when we had seen kind of what Google had done with Dremel, and at the time we also had a very close partnership with Google, and we're having discussions with them, and kind of made sense to look at how can we take that kind of technology and make it more broadly applicable to general industry.
So for listeners who still may not understand what Drill does, one way to frame this is that Drill offers zero-day analytics. Can you define that term? What is zero-day analytics?
Sure. If you think about what a company has to do today, or an individual or any organization basically has to do today when they want to analyze data in coming from various places, they first have to find a way to get all that data into a centralized place, right? And then they have to go and define schemas. Somebody has to go and define the structure of that data, and all that has to be done before you can actually query it. And so this process, many people will refer to it as ETL, and that process takes time. It takes time because moving all that data takes time, especially when it's big, and it also takes time because you need to have humans involved. You need somebody to go and say, okay, these files that have just arrived from some internal application or some external data source, this is the structure. These are the fields, the columns in them. These are the data types. And so what that means is that it can take anywhere from 1 day to a month in some organizations to make new data available for users to query that. And a lot of times it's not just about a new data set, it's about changes to the structure of data. And so what happens in a lot of applications these days is that, let's say a developer has built an application, let's say a web app or a mobile app, and the developer will just go and add some new fields, especially in databases like MongoDB, where it's very easy to do that. They'll just add some new fields, and they'll tell the analyst or the product manager sitting next to them, hey, I added these new fields. You can query based on that new field. And so the product manager goes in there and he's like, well, I'm trying, but that's actually not showing up. And so they have to go to IT and file a support ticket, and it takes 3 weeks, and finally they can query that new field, right? And so Drill aims to solve that problem by saying, basically allowing a user to query any data without having to kind of predefine schemas. So Drill automatically understands what's in the data, automatically handles situations where the data structure is changing and evolving over time. And so you can immediately query data, basically the real-time data, right? And so that's what I mean by zero-day analytics. You can query data that's 0 days old.
Right. And as you've said, it unifies the data format. So data in the world, as you've said in some of your talks, it exists mostly in 4 different schemas. What are those different categories?
There's lots of different definitions of schema, but when you think about the data that a company has, even in the most simple case, there are lots of files. There are lots of files that are structured as kind of delimited or text delimited, things like log files or CSV files. And then you have a lot of JSON files that are JSON has become a very popular data source for applications exchanging data, as well as kind of logging and persisting of data. So that's another type of format. And then you have relational tables, relational databases. People still have a ton of data in systems like MySQL and Oracle and SQL Server. And so that data has yet another kind of structure. And so Drill supports all these structures and kind of creates a unified view that allows you to query data no matter what structure it's in, and then also being able to join data across these different sources, even if they have different structures. So I could join a MongoDB table with an HBase table and my log files in Hadoop and my customer table in Oracle.
Engineers love automation, and Wealthfront automates your investing. As a software engineer, there are certain processes that you want to execute no matter what, like integration tests during a build. You wouldn't execute integration tests manually. You would use a continuous integration tool like CodeShip or Jenkins to automate your integration tests. Wealthfront is a tool to automate investing. Just like a continuous integration tool runs your tests automatically, Wealthfront can reinvest your dividends automatically and perform tax loss harvesting automatically. To get your first $15,000 managed by Wealthfront for free, go to wealthfront.com/sedaily and get started with Wealthfront's layer of automation on top of your portfolio. Wealthfront.com/sedaily. Check it out. It would support Software Engineering Daily, and you will get $15,000 managed for free if you sign up. Automate your investing. Get back to the things that you can't automate, like writing code. The relational model of a query engine it's useful for data that's in a CSV or a TSV format, but it's typically not as useful for a schema-free format like JSON or HBase. Why not? What are the problems with a JSON format that makes it harder for a query engine?
Sure. There are actually a few different problems there. So the first problem, if you look at a system like HBase or MongoDB or just a file full of JSON records, is that any record could have a different structure to it. In practice, what you see is that it's not that really every record has a different structure, but the structure evolves over time, right? So just, as I mentioned earlier, the developer adds a new field or decides that instead of name, there's going to be a first name and a last name, right? Or that the time is no longer a string, it should actually be a timestamp data type, right? So all these changes are happening rapidly these days as developers are kind of building and updating applications. And so that's the first thing that doesn't kind of fit the relational model. The second thing that doesn't fit the relational model is that these structures like JSON support things like nested fields. So you may have, say, an address field that's not just a piece of text, but actually has several fields nested underneath it, like the street, the city, the zip, the state, the country, right? So it has that kind of nesting, which the relational model doesn't support. And then it also has arrays. So if you look at various JSON data sets, a lot of times you'll find that there's an array. So if it's a data set of restaurants, you'll have, let's say, the categories of the restaurant. So each restaurant would have an array of categories. And that's also something that you can't really handle with the relational model. The relational model doesn't really support arrays.
You describe JSON as essentially a superset of all these other formats, if I'm quoting you correctly. Can you explain that reasoning?
Sure. When you think about all the kind of different data models that are out there, whether it's the relational model, which is what you see in, say, a MySQL table or a CSV or a TSV file, or you look at things like Avro or protocol buffers, that's another type of format that has a schema but supports nested data. And then you look at things like HBase, for example, where you don't really have any nesting or arrays, but you do have basically kind of a sparse table where you don't really like any record could have different fields. And so all of these different kinds of structures are basically special cases of the JSON structure, right? So to take an example, let's say you had a relational table, and so that means that every record in that table has the exact same set of columns or fields, right? And so you could represent that very easily as a file of or a collection of JSON documents where each of those JSON documents happens to have the exact same fields, right? So that's an example where, okay, it's very easy to represent that as JSON. And all of these other structures can be conceptually or logically represented as JSON with various kind of restrictions, right? So JSON is the most flexible format. And what we realized with when we were kind of looking at how to design Drill or how to build a system that would be very flexible was that if we could build a system that where JSON was kind of the de facto standard data model, then we would be able to query any data in all of these other more restricted or less flexible formats.
And Drill allows for SQL on everything, which, as we've discussed, is very useful for this business analyst, this typical prototypical role. And SQL on everything means SQL across all of these formats. What are the high-level challenges that you encountered while you were designing Drill, while you were thinking about Drill, just from a high level? What were the challenges that you were faced with?
Yeah, so Drill is designed for, like you say, SQL on everything. We still have to add kind of the ability to connect to different data sources, right? So, for example, we're working on a connection to, say, Cassandra, right? That's not a data source. We don't have a connector to that, but the engine of Drill is designed with that flexibility in mind. So adding these sources is possible, right? And it's also fairly easy. And the same goes for different file formats, right? So, Drill is very extensible. You can add what's called a format plugin that allows it to parse a new type of file. It also has storage plugins that allow it to talk to new kinds of databases and really understand also the internal capabilities of those engines. So one of the nice things about Drill is it will actually push down as much processing as possible into the underlying source. So if we're querying data on S3 or on HDFS, then we actually Drill does all of the execution because the underlying system has no query capabilities at all. When Drill is querying MongoDB, for example, it recognizes that MongoDB is able to do filters internally and things like that, so it can push down as much processing as possible into the MongoDB engine. And the same goes for a relational database. So if, for example, you're running a query that joins a MongoDB collection with Oracle table, maybe a few Oracle tables, Drill will actually do a preliminary join inside Oracle of all the data within Oracle and push down all the projections and filters into these systems, and then only pull out the data that it actually absolutely has to pull out in order to do the join across the two systems. And so one of the challenges here is understanding the internal capabilities of each of these systems, being able to push down as much processing as possible. The other challenge, of course, is the flexibility in Drill's engine to even be able to query data that doesn't have a strong kind of rigid schema, right? So every other SQL engine in the world that's ever been developed makes an assumption that the schema is known upfront before the query actually runs, right? So if you think about a relational database or a SQL on Hadoop technology, they all have a schema that's well defined and known upfront and doesn't change for that entire data. And that makes it a lot easier because the engine can then take that schema, compile the query into kind of what's called a query execution plan, and then run. With Drill, because the structure of the data isn't known in advance, right? For example, if you have a directory of JSON formatted log files, we actually won't know the structure of the data until we've actually seen the data, right? And the structure could change. It could be that the last record in the last file in that directory has a completely different structure compared to everything else. So the engine has to be much more flexible in terms of being able to adapt kind of the execution plan based on the data that it's seeing. And that's a much, much harder thing to do.
So I think what we're getting at here is that one of the big advantages of Drill seems to be this modularity. It's a layer of abstraction that sits over Mongo or Hadoop or whatever your data source is, and the access logic for the end user is going to stay the same, even if you change the underlying storage. And this is really useful in a super fast-moving Hadoop ecosystem. Would you say that's accurate?
Absolutely. Drill gives people a unified way unified and standard way to explore and analyze data regardless of what system it's in. So from a Drill user standpoint, a Mongo collection looks just like a directory of log files in Hadoop, and they can be queried in the exact same way. And it also makes it very easy to join these data sets. Although the underlying systems are very, very different, obviously, Drill makes it very easy to work with all of them because it's basically the same thing. You don't have to learn a different query language for each system that you have in the company.
What kinds of different data sources can Drill connect to right now?
So Drill supports HDFS, it supports Amazon S3, it supports Azure Blob Storage, basically any distributed file system that's out there, virtually any distributed file system that's out there. It supports some NoSQL databases like MongoDB, like HBase, for example. It supports relational databases, Oracle, SQL Server, MySQL, Postgres. People have used it with others like Netezza. And so it's a broad range of data stores that are supported.
Can you talk in more detail about how you write a Drill connector? Like whatever would make a good example. I don't know. Like how did you write the connector for S3 or the connector for whatever other data source might make for a good example?
Sure. So maybe let's talk about the connectors for kind of databases as opposed to file systems, because the file system, there's kind of a general purpose connector already, and that will basically work with any distributed file system as well as a non-distributed file system. So if you're adding support or a connector, if you want to build a connector for, say, a NoSQL database, right? You basically you're building a Java jar file at the end of the day. That's kind of what you're building, and you have to implement some interfaces that are defined by Drill. And so At the most basic level, you're defining an operator that knows how to read or pull data from that system. So given the name of a table, and there's kind of a way to specify names in Drill, but given a name of a table, being able to return kind of one record after the other. That's kind of the most basic level. But the more interesting kind of work here is really understanding what that database supports in terms of processing capabilities, and then being able to push down the processing as much as possible. And the storage plugin has the flexibility or the power to actually override any optimizer rules. And so if you're building a storage plugin, it would look at the logical execution plan and say, okay, I see that, for example, this query includes a join which has maybe 3 tables coming from MongoDB, or maybe that's not a good example. Let's say MySQL, and that data source knows that, or that storage plugin knows that MySQL supports joins internally, so you can actually ask, or it can actually take that and transform the plan so that the partial join happens within the MySQL as opposed to all the data being pulled out into Drill first. And so a storage plugin has basically an unlimited amount of flexibility to rewrite the plan.
Okay, so Wikipedia says Drill supports data locality, which means it is a good idea to co-locate Drill and the data store on the same node. Can you describe that quote in more detail?
Sure. What that means is that if you run, so Drill is a distributed system, right? The way you run Drill is there's basically a daemon process. We call it the drill bit. You run that on one or more servers. And so if your main use case is you're querying data in Hadoop or you're querying data in MongoDB, if you were to run that process, that drill bit on each of those servers where the data source is running. So let's say if you're running on Hadoop, running a drill bit on every data node. If you're running on MongoDB, running a drill bit on every Mongo node in the cluster. Then when Drill actually compiles the query and generates an execution plan, a physical plan, it will optimize that plan for minimizing the amount of data read over the network. So you think about the underlying storage system, say Mongo or HDFS, different pieces of data reside on different nodes in the cluster. And so by understanding where each piece of data is in the cluster, Drill can be more efficient about how it's reading data. And so basically each node in each process in the Drill cluster will read data that's on the node on which that's running. So we end up moving a lot less data over the network. That's not always possible though, right? If we're querying data from S3, there's no way for the Drill processes to run on S3 because S3 is a service. It's a black box from, that Amazon just hosts, and that's fine as well. In fact, I think as networks are getting faster and faster, and a lot of companies now, you see 10 gig as a standard and 40 gig coming up in many organizations. I actually predict that data locality will become less important as time goes on.
Yeah, I did a show with somebody from Netflix, and Netflix's entire data warehouse is in S3. So maybe is that unusual, or is that what you're saying? That's the direction we're moving in.
Well, I mean, the question about cloud is an interesting question. I had the opportunity to present to 50 CTOs on Wall Street recently, and we kind of did a show of hands asking who has more than 5% of their data in the cloud, and none of the hands went up. So I think, we talk a lot about cloud, but it's really the new generation
secure to be in the cloud
that can really take advantage of the cloud, right? It's very hard if you're an on-premise company, if you kind of grown up that way to just wholesale move everything to the cloud. Netflix is kind of the poster child, I would say, of kind of AWS and using the cloud, and they've been very successful doing it. But it's very hard for kind of a traditional enterprise to just move everything to the cloud. I think regardless of whether it's cloud or on-premise, the networks are getting faster, and I think that's a big advantage for it changes some of the dynamics around kind of distributed systems and the characteristics of them.
So this is kind of off topic, but I mean, and I don't know how much you can talk about this, but like when these companies say we don't like they can't go to cloud or they haven't gone to cloud yet or whatever, and they're on prem, are they typically doing this because it's actually too hard to move to S3, or is it more like there's security concerns?
I think it's a combination of both, right? Now, if you think about it logically, I would argue that companies like Amazon could probably do a better job securing a data center than anyone else, right? I mean, that's what they do for a business. They're going to be very good at it, right? I still think there's some perception around that, though, that companies struggle with. But I think it's also just an issue of legacy. You go to an enterprise today, there are so many systems that are on premise. So many applications. One of the companies that we're working with has over 10,000 Oracle databases. Right? It's not something that you can just say, "Oh, I'm going to throw those away and move everything to EC2." Right? And a lot of existing storage systems and systems they've built over time and employees have changed and moved on and things like that. It's just really complex environments, right? If you are, if you're a new startup, as we are here at Dremio, then absolutely everything we do is in the cloud. I mean, we have we don't run any infrastructure on premise, and it's great, right? Any developer can spin up a bunch of servers in the cloud, use them for as much as we want, spin them down. But most companies don't have that kind of privilege.
Let's talk more about Dremio. What are you doing at Dremio?
I can't say a lot yet about what we're doing at Dremio. We're still in stealth. We actually started back in June. We're backed by two of the best VCs in Silicon Valley, Lightspeed as well as Redpoint. And our goal really is to make it so that it's easier for people to discover, explore, and analyze data. Dramatically easier than anything that's existed before. So we'll leave it at that for now.
So I've done shows with people from Confluent and Rokana and Cloudera, and there's an explosion of companies that are offering big data services and support that spring out of open source projects. What is the future of this ecosystem? Or maybe you can't talk about this at all, but I'm just curious, like at the cross section of business and open source, you can even talk about, maybe your experience at MapR. What are the challenges and what do you see looking forward at the cross section of business and open source?
Yeah. I think the way in which software and services are adopted has changed dramatically over the last 10 years. Right? It used to be that the first time you would learn as a potential customer, the first time you'd learn about something would be when the sales rep called you and took you out to dinner, right? Versus today, the way people would want to adopt software and applications is they want to download it or they want to try it out for free, and they'll make a commitment once they see that there's value there for them. So they need to be able to kind of realize some value before they actually go and spend a bunch of time talking to a sales guy and things like that. I think that's what you're seeing in the context of kind of open source as well as freemium models that are out there, right? And that's why most companies today are taking one of those approaches that allows people to see value in what they're doing before kind of making a big time commitment.
What about the future of Drill? What are the biggest challenges of Drill that have yet to be overcome?
I think it's what you'll see in Drill over the next year is a lot of new functionality around new data sources, even better performance, greater ease of use. At the end of the day, Drill is a very new project, although it's been kind of one of the interesting things about how the open source world works, right? Or some open source projects, and especially in the context of Drill, is that we started Drill. We announced that we were working on Drill back in 2012. Well, there wasn't a line of code written at the time, right? So it was the work is done in the open, right? You don't have to sit down and kind of in a stealth mode kind of environment go and build something for 3 years and then tell the world what you're doing, because the source code is going to be out there in open source anyway, right? So why not do the development in the open and people in the meantime can learn what this is and contribute. For example, the MongoDB support for Drill was contributed by 2 engineers at Intuit. And so, Drill was developed. It took about 3 years to develop this. It was released in June of 2015, right? So it's only been about 5 or 6 months now that Drill has been available and usable by people. And so that's kind of very early if you think about kind of the evolution of our product. I think we're seeing tremendous growth right now in terms of usage, downloads. If you look at the mailing list, you see many questions every day now from different users that are using it and trying it out and running it in production. And so I think the growth is going to continue to explode over the next year, and we'll see a lot of new features built by kind of core Drill developers as well as companies that are trying to use Drill, and they'll add support for their own data formats and their own systems that they have and kind of solve the problems that they have. And so we're definitely seeing that kind of growing ecosystem around the project.
What about the Hadoop ecosystem more broadly? What is changing in the Hadoop ecosystem that excites you, and what would you like to see change more?
Well, I think so. First of all, I'd separate kind of the big data ecosystem, which I think is broader than the Hadoop ecosystem, right? I think what you're seeing with Hadoop is basically a lot of new innovation at all layers of the stack, right? And so you see a lot of people doing or starting to kind of experiment with more streaming applications where data is coming in and they're doing something with that data as it's coming in addition to kind of doing the more standard kind of exploration and analytics of the data. So I think streaming is kind of an important use case. I think in general, you're seeing more and more adoption of this stack, right? At the end of the day, even though we've been talking about Hadoop and big data for a while now, most companies are kind of still in the early days of adopting that technology, right? There have been some examples of companies that have really taken advantage of it. Some of the largest retailers, largest credit card companies, but for the most part, there's still a long way to go in terms of people really realizing the full advantage. And so, I think between Drill and Spark, there's a lot of kind of innovation at the execution layer in the big data ecosystem. I think you're seeing continued innovation at the lower levels. So in terms of kind of storing of data, and so MapR released kind of a converged data platform that includes that kind of file system, NoSQL database, and streams in one platform. Cloudera released a very interesting columnar store called Kudu, which basically stores data in a columnar format and supports random kind of updates, which wasn't possible before using just a file system and columnar files in a file system. So a lot of innovation at the kind of storage layer as well. I think outside of that, you see things like MongoDB and Cassandra and Elasticsearch also adding lots of new features. And so at the end of the day, it's, I always joke that if it's a great world to be a developer in, right? If you're a developer today, you have so many tools and so many options. For the most part, they're all free. They're open source. They're very scalable. They're very easy to build applications with. If you think about Drill, Spark, MongoDB, Elasticsearch, all it's just easy. It's way easier than it used to be, right?
Yeah.
Yeah.
We did a show on Kudu in case listeners are more curious about that project. So I'd like to begin to close off. To get some historical context, there are a lot of longtime database scientists who are involved in Drill. These are like people from Oracle and Vertica and so on. And I'm curious what it's like working with these people. Do you feel like databases and data access domains, is this a field that is changing at a fundamental level, or is it a case where history is repeating itself and the more things change, the more they stay the same?
I think the best innovations are the ones that both learn and take advantage of all the existing knowledge that's out there in the previous research and previous systems, and then build on that existing knowledge and innovate, right? It doesn't make sense in my mind to throw away everything we've learned in the past 10 or 15 years, right? And then, we'll run into the same problems, obviously, right? We'll do things differently, but we'll run into the same problems. And that's been one of the most important things for us in Drill. And also, if you look at the composition of the people working on it, you see people that are, very, very experienced database engineers, a lot of experience at companies like Oracle and so forth. But then you also see people that are more on the distributed systems and kind of developer focused kind of mindset. And so you bring those two audiences together, you get to take advantage of all the existing kind of domain knowledge that's been accumulated in things like optimizers and SQL and execution technology. But you also then incorporate kind of the flexibility that's required for the flexibility and agility that are required for 2015.
Well, Tomer, thanks for coming on to Software Engineering Daily. It's been awesome talking to you about Apache Drill and the big data ecosystem. I was about to say Hadoop ecosystem, but I won't say that anymore. So thanks again. It's been a pleasure.
Yeah, thanks for having me.